Robinson. Hey, Kalen. Hey, Corbin. Hey, Ben. How's it going?
All right, 5B says at the instant when the area of the circle is 25 pi, find the rate of increase of the enclosed area between the circle and the square. Okay, so if I have, and this is a bad drawing, but
Good to me.
deal with it. What we want to find is this area, isn't it?
Yes.
So is that the area of the square
Yep.
minus the area of the circle?
Yes. Yes.
Okay. What is the area of the square?
That's
Well, isn't this right here R?
yes.
So does that make this right here 2R?
Yes.
So what's the area of the square? Is it 2R times 2R?
Yes. Yeah, so 4R squared.
So 4R squared minus, what is the area of the
25
circle? But it's changing.
Oh, so it's just
So it is pi r squared. Right? Now, I think in part A, we said the radius is equal to the circle over, or the circumference over 2 pi.
that's the problem.
Huh?
That's the problem.
What's the problem?
That's the problem.
Do you agree with that?
Yes.
So everywhere there's an R, I'm going to put that.
Yes.
So the area that I'm trying to find is equal to 4 times c squared over 4 pi squared. Is that right? Minus pi times c squared over 4 pi squared. You all agree with that? I'm going to simplify it and take the derivative. To simplify it, my area is equal to c squared over pi squared minus c squared over 4 pi. What am I going to do now? Take the derivative. Is 2c over pi squared c prime minus c over pi c prime.
What are we getting me going?
Didn't we know that c prime
is
6? And I thought we knew c. We do.
But 25 over 5. 25 pi. Okay.
20, no, c is not 25 pi. Area is 25 pi. Is an area pi r squared?
Yes.
So what is r? Pi?
Say that one more time.
Area is pi r squared.
Yes.
And area is 25 pi.
Okay.
So what is r?
Take out the pi, it's 5. Okay.
R is 5. So c must be what? 10 pi.
C is the circumference.
Yes.
Okay.
So I have c, I have c prime, I can find a prime,
Yeah.
right?
Yes.
That makes more sense? Where are we going next? Can you guys hold that to finish it?
Yeah, we're going to 6 now.
So we can make sure we, 6A?
Yes. I don't know. I haven't looked at 6A.
Okay, why haven't you looked at it?
Because I looked at the first part, and I was instantly confused because I didn't know how to set it up.
So you didn't even try?
I did try. I just didn't.
I tried and I even got an answer. It might be wrong.
On
I
A?
tried and gave it for which one?
On 6A? 6A was really easy,
Oh
guys.
yeah. I did do 6A.
6A was super
I need
easy.
some questions.
Don't you know what volume of the cone is?
So this is what you got right.
I don't know the volume of the cone, personally.
You don't?
Yeah.
So it starts with finding the volume.
Isn't it 1/3 pi r squared h? Haven't we done that about?
Yes, I just forgot.
Okay. And basically, substitute for r and get rid of it.
Get rid of what?
R,
Oh, okay.
because they only want it in terms of h. What's next?
6B. I don't think I did it right because me and then we got different answers. But
On 6b?
yes.
But what rate is the volume of the water
Unless
changing?
we plugged it in wrong. This is kind of sad.
Isn't h 3?
Yeah.
So didn't you have this? Pi over 27h cubed. Right? So all I'm going to do is take the derivative and plug in what I know. What's the derivative?
Where'd you get that?
On A.
I got a way different thing.
Try again.
I saw it.
You had the right answer on A.
I did. Like I didn't simplify it. So like I had this one like before I simplified A, and then I did B, and then I realized I should simplify A.
So
So
B
I
prime is pi over 9 h squared h prime.
I got on A, H equals V.
It doesn't ask for h equals. It says find volume in terms of h, which means V equals something with h in it.
Oh, I thought it meant you wanted H with the volume.
No.
Okay.
So does that answer that question? So you should be able to get that one.
On our test, are you going to give us, like, if we need the area of the cylinder or something?
I will double check, but I think that's on there. I will double check it. So are we ready? Do you need C?
I think if I give B, what are we doing today?
Huh?
What are we doing today?
Finishing this and reviewing for the test. We've got to review the page that you have a test on tomorrow.
Is it just going to be one problem, or will it?
For tomorrow morning. Yes.
What kind of problem?
Finish so we can
I'm
give you
sorry.
it, and I will tell you what kind of problem. Do we not have an answer yet?
What's H prime?
I thought H.
H prime is given.
H prime is given, yeah.
Oh, H minus 12.
But don't you know H?
Oh, yeah. My brain is just falling apart.
So doesn't that make it -9?
Yes.
So can we go to C?
Yes.
I want to make sure we have. Okay, for C, is the volume of the cylinder equal to the area of the top times the height?
Yes.
Are you guys with me?
I'm still on.
Well, you're going to have to move on. We've got to get to where we can review. You can do that at home. Do you all agree? That's the volume of the cylinder. A is not changing in a cylinder.
Yeah.
Because when the water goes up and down, that how round it is doesn't change, does it? So I'm going to put the number in there. So V equals 400 pi Y. Right?
Where'd you get 400 pi?
It was given in the problem.
Oh,
So is V prime equal to 400 pi Y prime? What are we finding?
Y prime.
Y prime. And I know on B I found V prime because the volume is coming out of one going into the other.
Yes.
So if it's coming out of one negative, isn't it going into the other positive?
Yes.
So you know V prime?
Mm-hmm.
You can find Y prime?
Yep.
Good. Now what? Is that all your questions?
That's all mine.
That's all yours.
I'm so confused on B.
What?
So you got for your B prime equals pi over 9 H squared H prime.
Right here. That's
That's
B.
what I got. And then
Don't you know?
H prime is H minus 12.
Okay. Don't you know H and H prime?
You know H is 3, so would you just put pi times H minus 12?
Do you know H?
Yes, that's not.
Then how can you tell me an answer is H minus 12?
Well, you know H prime too.
What is H prime?
H minus 12.
What is H?
Oh, we can plug that in? I didn't know we could plug that H in H minus 12.
Oh, well, if you know H, you can plug it in everywhere. So we're good with that worksheet? Oh, it went, yay. Okay, first thing on the test is the page we're doing tomorrow. We're going to do it first. Then we'll review the rest of the test, how much ever time we have, okay? This is what the problem looks like. Close to what's on the test, it is not exact. Okay? Everybody okay with that?
Okay.
And I'm just going to ask you the questions in the order they are on that paper. You will be given that paper. You don't have to remember these questions. All right? First question. What is the domain? negative infinity to infinity. Why? Because there's nothing to restrict it, is there? They're not answering, are they? I'm going to come back to range. Okay? X-intercepts. What are my x-intercepts? How do I find x-intercepts? Set my problem equal to 0. And I don't know about you, but I would assume I could polysmolt it. So, do I have 0, 0, and 4, 0? These have to be points. We good with that? Everybody okay with that?
Yep.
The next thing is y-intercept. How do I find the y-intercept?
0 for x.
Plug 0 in for x. It also is a point of 0, 0. Guys, if you're not with me, tell me, because you've got to know this tomorrow, right? Now, what is f prime of x? 3x squared minus 8x.
Easy money.
Okay, you say easy money. However, if you miss this, it's going to affect the rest of the page,
Very true.
right? So double check your derivative. Right? All right. Now, when is f prime equal to 0?
Maybe some hammering out there, like an electrical thing.
Take a spoon and turn them on. When is f prime equal to 0?
Never.
Yes, it is.
Okay. 3x squared minus 8. Well, it's small. 0 and 0, obviously. It's 0 minus 0.
0 and 8 thirds.
0 and 8 thirds.
Oh, plus more than that. Okay.
When is f prime undefined?
Never.
Never. Do not leave that blank. Either write never or draw a line. Don't just leave it blank. I'm going to assume you didn't know what to do.
Why is it?
Because it's only undefined if it has x in the denominator. And it never does. Okay? Next question. When is the function increasing?
Set of x, right?
Yes. To find where it's increasing and decreasing, bless you. To find where it's increasing and decreasing, I set up my intervals from negative infinity to 0, from 0 to 8 thirds, and from 8 thirds to infinity, right? Oops. Is that right?
I would agree.
Now what do I do?
Now you plug in a number in each interval and see if it's possible.
Okay, so what number am I going to plug in here?
-1.
You want to put -1. I put it in the derivative.
Derivative. Derivative.
So you're,
Do you happen to have our assignment that we did this over?
I do.
Can you hand that back?
Yes, let me finish here and I will. So I'm going to plug -1 in the derivative. What do I get? Positive number. Then I'm going to plug in 1. I get a negative number.
I got it.
When you plugged 1 in, -5. And then I'm going to plug in,
so we're not using 4, 0.
I don't use the intercepts.
Okay.
No. I only use, under F prime, I only use 0 and undefined.
Okay.
I believe this one is positive. So it is increasing from negative infinity, that should be a negative right there, to 0, and from 8/3 to infinity, it is decreasing from 0 to 8/3.
Why don't we put the bracket up there and change it?
Because infinity never gets a bracket.
Okay.
Because I just finished working with my other class, telling them everything had to be in brackets, and my brain didn't switch here. We agree? Now, local max. Is it true that my graph goes up, down, and up?
I don't know.
I'm just, it says up, down, up.
Oh, okay.
So right here is a max.
Okay. Yes.
What is x at this point?
Should be 0.
It should be 0. Shouldn't it?
In the derivative.
0, the points are in the original. So it should be 0, 0. All right?
What do you mean the points are in the original?
This is, max is the point. So I put 0 in the original.
Okay. How did you know it was 0 again?
How did I, what was 0? The x or the y? Well, doesn't it show right here? It's going up and then down.
Yes.
So where does it change right there at this number?
0. Okay.
That's what that tells me. Now, where does it change right here?
From 3 to 8 thirds.
8/3. And that is a min.
Because, okay, we said every time it changes from positive to negative is when a max occurs, and every time it changes from negative to positive, then occurs.
Yes. And if you think about it, that means it's going up and then down, so that's a max. Down and then up is a min. What is my point? 8/3 what? Okay? Everybody okay with that? Okay. What is F double prime? Six x minus 8. When is F double prime equal to 0?
8. No, 6. No.
4/3?
Yeah, yes, that's 6 zeros.
Okay. What is F, when is F double prime undefined?
Never.
Never. All right?
The inception. Inflection point.
No.
Deflection.
Deflection.
How about concave up and concave down? don't I have negative infinity to 4/3 and 4/3 to infinity? You understand where that came from?
Yes.
Okay, pick a number between negative infinity and 4/3.
0.
0. When I plug 0 in, it is negative.
Oh,
When I plug 2 in, it is positive. So it is concave up from 4/3 to infinity, concave down from negative infinity to 4/3. Correct? Now, what is my inflection point? Where does it change from up to down or down to up? 4/3, and how do I find y?
Plug it into the original.
Plug it into the original.
okay.
What do I get when I plug it in the original? I have one blank left.
Oh,
Graph?
range.
The range.
Are we gonna have to sketch it?
No. What?
So whenever you are using the negative infinity to 4/3, that interval, what were you plugging that into?
The second derivative.
Okay.
Because it's under the second derivative, so it goes in the second derivative.
On like the last one,
Since I can be
you plug that to the,
It's a point.
or you.
It's a point on the last one. A point is always the original. I always plug a point in the original.
and that was for what next?
Inflection point.
I'm talking about on like the maxes and min.
Okay. This is a point.
Or increasing and decreasing.
That I plugged into the first derivative
Okay.
because it's directly under the first
And the
derivative.
concave up, concave down is pretty much the same thing just for the second derivative.
Yes, it is. One thing left, and I want you to look. Didn't I kind of sketch a graph right here? How far down is this graph going?
Infinity.
No. How far down?
Yeah.
8/3.
No, look right here. How far down is this going?
Negative infinity.
How far up is it going?
Positive infinity.
So my range is negative infinity to infinity.
She tricked me with that. I said infinity. She said nope, and I was like, what could it be then? And I
Well, it can't be
said
infinity going down.
What was the inflection point again?
You just plug the.
4/3 negative 128/27.
You plug the f prime into the original. So if there's multiple.
I never plugged f prime into the original. No.
Not the original,
I never plugged f prime anywhere.
not f prime. F prime equals 0.
Yes.
Okay.
Yes.
And then if there's multiple of those, you do all those, and you get multiple points for inflection.
Yes.
Okay.
That was f double prime though.
That's fine.
All right, we good with this?
Can we discuss inflection point one more time?
Inflection point is where it changes concavity. So anywhere it goes from concave up to down or down to up, that's the x value. Find the y value, it's in the original. Okay? Everybody good with that?
We're good. See you guys later.